Yeah, my name is Alec Czarowicz, and I'm the VP of Sales at Organic Motion, based in New York.
And did you see a need for this, or did somebody approach you and say, we need something like this product?
Well, that's an interesting story actually, and it goes back 9 years actually, where Andrew Chesnock, the founder of Organic Motion, was looking for tracking solutions. So he went out, and the only thing that he found was really marker-based or sensor-based or suits. And he thought, wait a minute, is there nothing around that comes with no markers and no sensors? There was nothing. So what he did is he basically sat down and programmed the code on his own. So I remember him sitting in his bedroom and coding along with first camera setup, first whatever, and that's how it started really. And in 2006, the company became a big company, and we started out there, and I joined the company in 2007.
And explain to me, for the common man, how does this system work?
Well, it's in general, it sounds very simple, right? It's a 3-step approach, where we have a set of video cameras. Those video cameras are VGA, stream regular video, so no infrared and nothing. Stream video to a computer vision system. And what we do in there, we kind of do a 3D reconstruction of the person in the space. So that means we build a 3D clone, a 3D scan point cloud of you. So we have your entire, so in that sense we have like 1,000 surface point, if you will. And once we have that, in the third step we do a character fitting. That means we kind of map a skeleton into that point cloud through our software algorithms. And once we have that, we are then able to drive 21 bones in 3D. So we give you the position in space, and we give you the orientation in space of those bones. And that data is then available for output either through an SDK or through a plugin into animation software programs or biomechanical analysis software programs.
And how is this an improvement on some of the systems that have been in existence for a while now?
Well, I think the fact that it's markerless. So kind of really streamlining the entire process of motion tracking. So the idea where you had before, where you have still the process of setting someone up, having someone putting on a suit, gluing markers on certain joints. I mean, this is completely gone with the Organic Motion system. You come as you are, and you have instant access to motion tracking. And that includes the calibration and subject calibration, which is instant really. So imagine you come, you see the system, there's a room, you step into the room, you take the T-stands, and you are tracked immediately in real time. And the data is there in real time as well. So you see yourself as you drive an avatar, or you see your data as it comes out of the system while you are in the system. So it's much less time, less effort, quicker, faster than when you had to work with the marker-based systems.
Is there other products in development that are similar to this, or is this cutting edge, would you say?
Well, there are several universities who work on markerless motion tracking as well. One being Stanford, there's a group in Germany, in Saarbrücken, they work on that. And I think maybe 1 or 2 more groups that specifically go into the direction, but nothing commercially available as of now.
And what are some of the applications that you have? I noticed you demoed a few for us today. What are some of the biggest applications of this product that you have seen?
Well, we work in four industries, or 4 main markets, if you will. One is the animation, digital arts and digital media. On the commercial side as well, on the educational side. This is huge, where you have an integration to game engines, where you develop games, animation, visual effects and such. Secondly, the life sciences. Think about you want to measure the velocity of a joint of a certain angle. So clinical applications, sports applications, so in the athletic. Thirdly, training and simulation, where we are currently very involved with military and defense contractors and the government directly, creating training and simulations systems for them. And fourthly, and this is actually a very fun part, is the public installations, so public use of the technology. Think about a museum where kids come in, there's this box, there's this cube, they step in, they can choose what they want to be. They want to be Mickey Mouse or Donald Duck or whatever, and all of a sudden they drive this avatar right in front of them. They have lots of fun doing that. So those are the 4 different main areas and applications.
And I noticed that you had a 2.0 that you sort of gave us a preview of. What are some of the improvements you're looking forward to with this system?
Well, a few improvements. First, with the new 2.0 you can track not only one person, but multiple people. So 2, 3, or even more at the same time. You also can now in addition track objects. So if you had a ball, if you're simple objects, you want to track that too, Markerless, then that's possible with the system. The new system does not require anymore this white backdrop, so in that sense it's more flexible and also more portable, more expandable, depending on your room or space requirements. I would to say that are the main differences. And the software, the underlying software is such that it's an open framework. So this software is broken up in modules. Let's say you have a tracking module, you have a calibration module, you have a synchronization module, which means that now researchers, they do computer vision for example, can actually pick one of those modules, add their own code, add their own hardware, and create a completely new computer vision system, if you will. That is very exciting too, we believe.
Very interesting. Is there any other comments you would like to make about this system?
I think we touched the main points. Good questions.
There's one other thing, but you kind of touched on it, the implementation of other technologies along with this. Mm-hmm. You said that it's modular, so it can support. What kinds of things can it support? What have you seen people use in tandem with organic motion?
So, on the animation side, there's the integration to Motion Builder. Mm-hmm. Right, so there's a plugin where you kind of walk in, you have the Motion Builder up and running, you have a character there, and then you really only work in Motion Builder. Our system basically stays in the background. You really don't have to touch it. There's no specific technician that has to come in and explain things and set it up. The system's always up and running basically. So when you want it, you need it, you just go there, step in, do this, and you're ready to go. And you stay in your own environment, your own familiar software package, which is the Motion Builder, right? So on the life science side, they have the integration to biomechanical analysis. So if you want to measure for sports or clinical applications, if you want to measure the angles, the velocity of joints, whatever that might be, then it's the same idea, right? You come in, you step in, you walk, you see yourself walking, and the other thing is, if something goes wrong, if there's something breaks down for whatever reason, you see it immediately, right? So you just do it again, right there and then. While if you had a system that is not real time, you capture data, and then after the fact, you realize that the data is broken or no good. That person that you worked with is already gone, that patient, for example. So that's probably another very important thing. So you can educate the patient by letting him see what's happening, and you can tell him, look, this is what happens in your gait, these are the changes. You can educate the patient in this way. And then through the SDK integration to all sorts of other visualization softwares or analysis software packages, so game engine like Crytek, Unity 3D, Unreal 3 engine, 3D VIA is possible, has been done. It's the same way. Real time, step in, you drive this.